So I'm trying my special series again in this new format. I hope it'll be shorter and much more clear than the previous series. This video will be about infinite arithmetic series. So let's get started. What is an infinite arithmetic series? Let's break it down. What's a sequence? A sequence is a set of numbers, and an arithmetic sequence would be a set of numbers in which the common difference is constant. So in this case, it would be an infinite arithmetic sequence because the common difference is 1, and that's constant throughout the sequence. An arithmetic series would be the sum of all the terms in an arithmetic sequence. So this would be an arithmetic series. Infinite arithmetic series basically means that it goes on towards infinity. This looks a bit like our title, so let me explain. Our title said that this is equal to negative 1/12. The title of this video explicitly stated that. Well, this is not wrong. We're gonna actually prove this. It looks very wrong because it goes on forever, so shouldn't it be infinity? And plus, all of these are whole numbers, so if it wasn't infinity, the answer shouldn't be a negative fraction. How does that make any sense? Well, we're gonna prove that today. And it won't be that easy, but we're gonna prove it. So let's get started on the proof. First things first, we're gonna define a new series x. X is equal to 1 plus negative 1 plus 1 plus negative 1 all the way to infinity. If you look at this series, you think it should be 0. The answer should be 0 because you're just adding 1, subtracting 1, adding 1, subtracting 1 all the way towards infinity. Well, the thing is, it can either be 1 or 0. If you look at the first term, it's just 1. If you look at the first two terms, it's 0. If you look at the first three terms, it's 1 again. 1 minus 1 plus 1 is 1. And then if you look at the first four terms, it's 0 and so on. So it just alternates or oscillates between 0 and 1. So which one is it? In truth, it's neither 0 nor 1. Let's go through an algebraic proof of this. The first thing we can do is we can subtract 1 from this series. X minus 1 is basically equal to the same series without the first term because the first term is 1. So if we're subtracting 1, we can get rid of the first term. So it'll just be negative 1 plus 1 plus negative 1 all the way to infinity. Since they're infinity terms, it doesn't really matter if we take away 1. In theory, they both have the same amount of terms because it's still infinity each. So how does that help us? Well, if you look at each of the terms of these series, 1 to negative 1, negative 1 to 1, 1 to negative 1, and so on. If we continue, we see a pattern. Basically, each term in the second x minus 1 is basically equal to the negative of the term in x. So the term in the second one is the negative of the term in the first one. I'm discarding this for now, just keeping it up here for now because that's what we're trying to prove, not an actual series that we know. So I'm just calling this one the first one, this one the second one for now. So what we can do with this is we basically can say that this is equal to negative x because it's the negative of each term in the series. So now this is monumental because we can just set the first and third parts of this equation equal to each other. So x minus 1 is equal to negative x. Add x to both sides like an equation. Add 1 to both sides. You get 2x is equal to 1, which means x is equal to 1/2. There we go. We solved for a series. X is equal to 1/2. It looks odd because we thought it would be either 1 or 0. It's neither because since it's either 1 or 0, there's equal probability that it's 1 or 0, which means you just take the average of the values, which is 1/2. That's like a shorter, less understanding. Like, you can't understand it as well because it could be wrong. This is algebraic, so it's for sure true. That is just like, once you prove this, that's just like, oh, that makes sense now. Like, why it was 0 and 1, whatnot. Back to this. Now that we know this is equal to 1/2, we can create a new series, y. Y is equal to 1 plus negative 2 plus 3 plus negative 4, and so on all the way to infinity. Let's see if we can find out what this is. We can't do much with just y, so what if we do x minus y? Well, x minus y, let's see what we get. X is 1, y is 1. So I'm just taking the term by term right now. So 1 minus 1 is 0. What's negative 1 minus negative 2? That's negative 1 plus 2, which is just 1. What's 1 minus 3? That's negative 2. What's negative 1 minus negative 4? That's negative 1 plus 4, which is 3. And it goes on towards infinity, but there's a pattern here. It's basically equal to y, because the 0 doesn't really do much in this series. Since you're adding the terms together, you can just discard the 0. So it'll be 1, negative 2, 3, soon it'll be negative 4, 5, negative 6, so on. It's basically equal to y. So now we can set up an equation similar to what we did last time. X minus y is equal to y. So we can add y to both sides, and we'll get x is equal to 2y. This seems like we hit a dead end because there are two variables and we can't really solve for two variables. But remember, x isn't really a variable because we know that it's equal to 1/2. So 1/2 is equal to 2y, which means y is equal to 1/4. There we go, we did it. We solved another series. Y is equal to 1/4. Now, we finally have enough to solve for the series S. This looks a bit related, but not sure what we can do with it, right? So let's try something similar. Let's subtract S and Y. S minus Y is equal to, so what's 1 minus 1? 0. What's 2 minus negative 2? That's 2 plus 2, which is 4. What's 3 minus 3? That's 0. What's 4 minus negative 4? That's 4 plus 4, which is 8. And so on. 0, 12, and so on. If we continue this. Again, we can discard the zeros, and we're left with 4, 8, 12, and so on. Now, this looks a bit familiar. It's basically equal to, if we can factor out a 4, it's basically equal to 4 times 1 plus 2 plus 3, and so on, all the way to infinity. Now, it's basically equal to 4 times, and what is this series that we have? 1 plus 2 plus 3, all the way to infinity? Well, that's just S. Now we have 4S. 4S is equal to S minus Y. This is a nice equation, and we're almost there. We just have to solve this equation, and we find out what S is. So I'm just gonna remove these for now, so I have enough space to solve the equation. 4S is equal to S minus Y. Subtract S from both sides. We get 3S is equal to negative Y. Again, we can substitute in Y. We know Y is equal to 1/4. So it'll be 3S, 3 times S is equal to negative 1/4. Divide both sides by 3, and we get the intended result. S is equal to negative 1/12. Like I said from the start, S is equal to negative 1/12. This is our final answer. We are done with our proof. If you have any questions on the proof, let me know in the comments below. I'll be happy to explain a part of it, or you can rewatch this video. This is our proof. The sum of an infinite arithmetic series is negative 1/12. I will be posting a follow-up video to this. It'll be more on infinite arithmetic series. Instead of just solving for 1 plus 2 plus 3 plus 4 plus 5 plus 6, it'll be solving for a general series with any common difference D, with any starting term S1 or T1 or whatever you want to call it. We'll be solving for a general arithmetic series and a general solution given this proof. So I hope you like this video. This is about infinite arithmetic series, and welcome back to my specials channel. See you next time.